This video is on simplifying by combining like terms. We will also throw in problems where you are going to combine like terms and also distribute in one problem. So just as a reminder, a like term means that the terms have the same variable and the same exponent. So if we had 3y squared and negative 10y squared, those are like terms because they have the same variable and the same exponent. 2 plus 5x, those are not like terms. This has an x, this doesn't. 3y minus 10, those aren't like terms. This has a y, this does not have a y. 4y and negative 8y squared, those are not like terms. This has a square or an exponent of a 2. This one has an exponent of a 1. So these are not like terms, and these are like terms. We can combine 5 minus 8, that's negative 3. So anything that we can combine together is a like term. So let's see why it works to be able to put these together and combine them to make 7x. And this would make 3 minus 10 is negative 7y squared. And this would be negative 3. But why it does not work to do that over here. So let's prove it. So if I pick a random number, so let's say I'm going to have x be 2. So if I plug in, first of all, if I combine these together, if I say, which it's not going to be equal, okay, but let's pretend we say that 12x minus 8 is 4, or 4x. Let's see if that works. If we plug in a 2 here, then we get 12 times 2 is 24, 24 minus 8 is 16. If we plug in a 2 here, we get 4 times 2 is 8. They aren't equal. Therefore, 12x minus 8 is not the same thing. It does not have the same value. It does not simplify to 4x. So we can't put these together because they don't have like terms. They don't have the same variable. But here, we can say that 12x minus 8x is 4x. So if we plug in a 2 here, and we plug in a 2 here, so we have 12 times 2 is 24. And remember, we have to multiply before we can subtract, so we're going to multiply here. So 8 times 2 is 16. And then 24 minus 16 is 8. Well, if we plug in a 2 here, 4 times 2 is 8. It works. So you are allowed to add or subtract, combine terms that have the same variable and exponent. But you cannot if they do not have the same exponent. So let's do some examples here. And remember, when we're combining like terms, we are adding if they're the same signs, the terms, and we're subtracting if they're different. We're using our rules from earlier in the chapter. And then we look in front of the larger value if we assume they were positive, so absolute value. So here we can combine all of these because they all have x's. And I can combine these in any order as long as I'm looking in front of the number. So I can combine the 5x with the negative 13x, or I could do the 5x with positive 1. So those have the same sign, so I'm going to add. So 5 plus 1 is 6x. Then I can combine the 6x with the negative 13x. I can combine those. And those are different. This is positive 6, this is negative 13. They're different. So we're going to subtract 13, take away 6, is 7x. And since 13 is bigger, I look in front, there's more negative. So our final answer is negative 7x. So this is the same thing as this. And if you wanted to check, pick a random number for x and replace the x with that number, and replace it here, and you'll get the same thing here that you would here. But this would be quicker to do because there's only one term. We've simplified this into one term. Okay, let's take a look at this example here. So we can combine the 14x with the positive x because they both have x's. And this is 1, so 14 plus 1 is 15x. Then we can combine the negative 2y with the positive 5y because they both have y's. So these are different. This is positive and this one's negative. They're different, so we subtract. 5 take away 2 is 3y. Then we look in front of the bigger number. 5 is bigger, and it's positive. So we're going to put plus. And that is our final answer. We cannot go any further because this has a y and this has an x. Okay, here. Oh, and also one other thing here, back to this problem. This is the same thing as if we write it as 3y plus 15x. The commutative property tells us it does not matter the order. So as long as if this is positive 3, this one's positive 3. If this is positive 15x, this is positive 15x. So the order doesn't matter. However, the mathematically correct way that we're going to do it so everyone looks the same is we are going to write it in alphabetical order. And the constants go last. So remember, constants are numbers without the variables. So if we take a look here, and we start with the negative 3x, there's no other x term in this problem. So I'm going to just bring it down, and it's a negative 3x. And then I can combine the 5 with the negative 8, because they both don't have variables. This one's positive, this one's negative, so I'm going to subtract them. So 8 minus 5 is 3. 5 is bigger, so it's positive. And notice I put the constant at the end. It doesn't mean that if we put the 3 there and the negative 3x after, it does not mean that that's wrong, but we're going to try to get it in standard form with the variable first and the constant at the end. And if there was more than one variable, alphabetical order. Okay, let's take a look here. So we can combine these. These both have the same variable. So 1y plus 1y equals, they're both the same, they're both positive. We add them and we get 2y. Okay, the next one here, we have x, take away x. So we have 1x here, and we have negative 1x here. So if we have an x and we take an x away, we don't have any left. So 1 minus 1 is 0x. But we're not going to leave our answer as 0x because this can simplify. This is saying 0 times x. And 0 times anything, remember x is a number, 0 times anything is 0. Okay, let's take a look at this example. And remember, again, feel free to pause the video at any time to try the problem first. So here I see n's, I see an a, I see constants. So alphabetical order. So I'm going to start with the a, and that is the only one. So it's positive. So I'm going to put 5a first. Then I'm going to go with the n's, and I have a 4n here, and I have a negative 1 there, negative 1n. They're different. One's positive, one's negative, so we're going to subtract. 4 minus 1 is positive 3n, because 4 is bigger and it's positive if you look in front of it. Then we have a negative 7 and a positive 9. Those are like terms because they both don't have variables being multiplied next to it. So negative 7 plus 9, we need to figure out what that equals. They are different. This is a negative, this is a positive, so we're going to subtract them. 9 minus 7 is 2. And then we look in front of the larger number. 9 is bigger than just 7, so it's positive 2. And that is it. We cannot go any further because these two have different variables, and this is a constant. Okay, so take a look at this example. We're going to start with the x, because x comes before y. So we have 4x and negative 8x. They're different. This is positive 4, this is negative. They're different, so you subtract. 8 minus 4 is 4x. And then we look in front of the bigger number, which is 8. So that means there's more negatives. So negative 4x. Then we are going to combine the 5y squared with the 4y squared. And they're both positive numbers, so they're the same, so we add them. So 5 plus 4 is positive 9y squared. And that is as far as we can go. And remember, it would be fine if we wrote our answer like this, but this is better because it's in alphabetical order. Okay, let's take another look at another example like this. If we look here, I see lots of n's here, but they have to be the same variable and exponent. So if you see that they all have the same variable but some have exponents, you start with the higher exponent if they have exponent, if same letter. So we're going to combine the positive 1 n squared with another positive 1 n squared. So 1 plus 1 is 2 n squared. So notice we're not adding the exponents or anything like that. And then we have a positive 6n with a negative 5n. And they're different. One is positive and one is negative, so we subtract. 6 minus 5 is positive, because that's bigger, positive 1, and we don't need to put a 1 next to a variable. It's implied, because 1 times anything is just n, so we don't need to put that there. And then we have the positive 3 here and the negative 8 here that can be combined, and they are different signs. This is negative, this one's positive, so we subtract. 8 is bigger, so that means there's more negatives here, so negative 5. And that is as far as we can go, because these are not like terms. This has an exponent of a 2, this does not. Alrighty, now we are going to combine both lessons, distributive property along with combining like terms. So I see adding, I see parentheses, that mean multiply here, I see subtraction, so I need to turn to my order of operations to figure out where to start here. So first thing, it says parentheses, but if I look inside the parentheses, I cannot combine 3x minus 2. They're not like terms. I can't subtract them. So we cannot do parentheses. There are no exponents. Then multiply. Well, there is multiplication. That's what the distributive property is multiplying. So we're going to take this, and we have to look in front, and I like to draw a little line here so I know what I'm distributing. I'm distributing a positive 5 times 3x, so 5. Now we're multiplying, so now we're using our rules for multiplying. 5 times 3 is positive 15x, and then positive 5 times negative 2 is negative 10. Then I'm going to bring down the 3. And now what's in between the problem? Now we have adding and subtracting. So we're done multiplying and dividing. We can't multiply here because we don't know what x is to multiply these two. So the only thing we have left is adding and subtracting. So now we're using our rules for adding and subtracting, which is combining like terms. So if they're the same, we add. If they're different, subtract. So I'm going to start with the variable, and there's no other x's, so that's going to go in front. Then we can combine the positive 3 with the negative 10 because they both don't have variables. And together, one is negative, one is positive. They're different, so we subtract. 10 minus 3 is 7, but 10 is bigger, so negative, minus. So it's going to be 15x minus 7. Okay, let's take a look here. So same thing, we cannot do the parentheses first, there's no exponents. So multiplying and dividing, and that is what the distributive property involves, is multiplying. So since we can't do the parentheses first, we're going to distribute. But that's not a 4, that's a negative 4. So negative 4 times 2, a negative times a positive is a negative 8x. And negative 4 times negative 3 is positive 12. Then we bring down the 8. And there's no other x's in this problem, so I'm going to put that out first. And then we can combine the positive 8 with the positive 12. They both don't have variables. They're the same. They're both positive. This is a positive 8. This is a positive 12, so we're going to add them. Positive 20. So 12 is bigger, so it's positive 20. Okay, let's go ahead and take a look at another example here. Oh, we got a lot of things going on here. So start with parentheses. We can't combine those. They're not like terms. Can't combine those. Those aren't like terms. There are no exponents. Multiplying and dividing is next, and that is the distributive property. Involves multiplying. So I have that number in front of the parenthesis. That means times right there. So I need to distribute that number. And I have a negative 3 here to distribute. I have 2 in this problem. So negative 2 times 1 is negative 2x. Negative 2 times positive 5 is negative 10. Then negative 3 times negative 2 is positive 6x. So notice I'm using this with the negative 3, and so I'm using it. I'm not going to bring it down. So that's a negative 3 times a negative 2 is a positive 6x. Then negative 3 times negative 5 is positive 15. So I'm done multiplying. Now the last step is to add and subtract, which involves combining like terms. So at this point, the only thing in between are addition and subtraction signs. I can't multiply, even though that's what that means when a number is next to a variable, because I don't know what x is to multiply that. So I'm left with, we proved that combining like terms works, so we can put together these two because they both have x's. This is negative, and this is positive. They're different, so we subtract. 6 minus 2 is 4x. And then we look in front of the larger number, which is positive. Then we can combine the ones that don't have variables, so the negative 10 and the positive 15. And those two are different. This is a negative, and this is a positive. They're different, so we subtract. 15 minus 10 is 5. And then we look in front of the larger number, which is positive. And that is our final answer. Okay, one last example on this lesson here. So again, we got lots of stuff going on. Parentheses first, but we can't combine those terms that are in the parentheses. Exponents, there are none. And then we have multiplication and division, which that is what it means when a number is next to a parenthesis. So we are going to distribute that number. So 5 times 2y is 10y. And 5 times negative 3 is negative 15. Well, in front of this parenthesis right here, we have a negative sign, which says that we're going to take away 7y and negative 2y. So it needs to be distributed. It's saying that we're going to combine this with the opposite of 7y. And the opposite of 7y is negative 7y. And then the opposite of negative 2 is positive 2. So it changed everything in the parentheses to the opposite sign. So the 7y to a negative 7y and the negative 2 to a positive 2. Okay, now I don't see any multiplying that we can do. So now we add and subtract. We combine like terms. So we could put the 10y with the negative 7y. We can combine those together. This is a positive and this is a negative. They're different, so you subtract. 10 minus 7 is 3y. Then we can combine the negative 15 with the positive 2, because they both don't have variables. And this is a negative and this is a positive. They're different, so we find the difference. We subtract. Then we look in front of a larger number, which is 15, not negative 15, but 15. So we look in front, negative.